And it's recording. Here we go. 5G. Copy these notes down. So distributive law. This is given as the number on the outside of the brackets. You are going to multiply it to every term inside the brackets. Now, how many terms are there inside the brackets right now? Can I please have man? 2. Very good. It's 1 separated by a plus or minus sign. That's 2. So 2 terms. That means you do A times B. So write that in. A times B is the first one. A times B. And you have to also do A times C. That's the one that most students forget. They usually do the first bit, but they forget to do the second bit. So the second bit is A times C and separated by a plus or minus sign. Okay, so this is called the distributive law, that the outside number you times to B and the outside number you times to C as well. Write that down. That's your rule. That's the first sort of rule that you learn at year 8 level. Year 9, you start to expand on that idea. Let's do a bit of logic. Let's see what you know in terms of primary school stuff, right? 3 times 7. Now, I know the answer is 21, but I don't want the answer. I want the how. What does 3 times 7 actually mean? Yes, 3 groups of 7. And what that actually means when you write it out, it just means that's one group of 7. So if you count 7 people, like 1, 2, 3, 4, 5, 6, 7, that's one group, plus another group of 7. So if I count another 7 people, so 1, 2, 3, 4, 5, 6, 7, that's another group, plus a third group of 7. So 7 plus 7 is 14. 14 plus 7 gives you 21. Okay, sounds pretty straightforward, but I'm going to show you the pattern to how this rule actually comes about. It's not magic, it's logic. Let's have a look at the second one. So if 3 times 7 is 3 groups of 7, then what's 3 times 2? Can I please have Lucas? 3 groups of 2, which is written as? Beautiful. So 3 groups of 2 would mean 2 plus 2 plus 2, because I got groups of 2, that's one group, plus another group of 2, plus another group of 2, that's in total 6 people. Yeah? That's what 3 times 2 is. So using that same logic, what do you think 3 times A, or 3 groups of A, would mean? Let's go with Liam.
3 times A would be like 3 groups of A, so it would be like A plus A.
Beautiful. Now I did the same thing with the other group. I said A plus A plus A, which is 3 groups of A, and what's A plus A plus A equal to? 3A. We're too lazy to write the times. So that's what you learned previously, right? Then I asked the next room. This went quiet in the other class. So they did this really well. They did this really well. They did this really well. And all I did was change one small thing. Just have a look at the pattern. I went 7 to A. Now I go to A plus 2. So then I asked the class, I said this. I said, what is 3 groups of A plus 2 look like? Well, let's see. Who wants to answer? Sully. No, that is the final answer, but I want to know the working. See, I don't want the 21, I don't want the 6, I want the 3, I don't want the 3A plus 6, I want this. I want to see the logic. What is that, Kyle? Beautiful. Can you see the logic of what Kyle's saying there? See, this is one group of A plus 2, because we're saying we've got 3 groups of them, right? But for whatever reason, it happens to all year levels. It's always interesting. One number's fine, one letter is fine after you see the pattern, but as soon as I put a number and letter, it's like, well, I have no idea. It means exactly the same thing. The language hasn't changed. It's 3 groups of A plus 2, so that's one group. Plus, that's my second group. Plus, here's my third group. Now you might question, how did Sully get 3A plus 6? Well, let's look at this a bit more deeply. A plus 2 is the one group. A plus 2 is one group. A plus 2 is another group. That's 3 groups in total. But if you rearrange it, remember, the order of addition doesn't matter. Whether you do 2 plus 3 or 3 plus 2, the answer is still 5. So why do I have to write A plus 2 then A plus 2? I can actually rewrite them all as A plus A plus A. Why can't I write it all in one line? So it's just easier to see, right? So I've done A plus A, so that's my plus A there, and then a plus another A. So A plus A plus A is written here. And then I do 2 plus 2 plus 2, I just rearrange it. Now let's think about it. You just saw this line just now. What's A plus A plus A? The same thing as saying? 3A. It is. The final answer is 3A. But before that, that just means, yeah, 3 times A, 3 groups of A. So this is 3 times A, and then this one has to be 3 times 2. But can you see where the rule came from? This is how Sully got his 3A plus 6. But do you see the rule? If I zoom out now, why did they say take the outside number times every term? Because it ends up being, when I say 3 groups of A plus 2, I ended up with 3 of those A's, 3 groups of A's, and I also ended up with 3 groups of 2's. So why did I do all these steps when I knew already it was just 3 times A and 3 times 2? That's what this is saying. 3 times A, 3 times 2, that's what this is saying. Okay, so this looks confusing for a lot of students because it's letters, but I tried to break it down for you to see in terms of numbers. Yeah, and we can even do that in an application sense that, what does it actually mean? When do you ever actually do 3 times A plus 2? Well, if you think about it, it's like this. You know your year 8s, your A class? How many A classes do we have? We've got 8A, 8B. Well, maybe we'll just go up to E since I get to teach up to E. So 8C, 8D, 8E. I don't know. Oh, yeah, I think there is it. Oh, well, let's make it up. 8D, 8F. Yeah? Now, how many classes are there? There's 5 there, yeah? So 1, 2, 3, 4, 5. This is what I'm teaching you in terms of expression. That's an expression. How many terms are there? 5. 1, 2, 3, 4, 5. Separated by plus and minus signs. But that's just your classes, right? What's common about all these classes? They all start with 8, or they're all year 8s. So what you can do, instead of writing 8A, watch the punchline here. Instead of writing 8A, 8B, 8F, 8D, 8E, I'm repeating that 8 so many times. So why don't I just write it as 8 groups of, now which groups do I have? I've got A plus B plus C plus F, oh sorry, not C, F, E, and D. This is what's different about all the groups. This is what's common. This is called factorizing. When you expand it, is you do this. You do 8 times A, so that's 8A. 8 times B, that's 8B. 8 times C, also 8F. And then 8 times D gives you 8D. That's what you're doing right now. You're doing expansion. But really, factorizing and expanding, what's the application? It's to group what's similar and what's unsimilar. That's what's similar, common. That's what's uncommon. So if you think about like biology, you would be thinking about animals, mammals. What do they have in common? They might have, warm blood cells. And then what is uncommon about them? One has wings, one doesn't have wings, one has 4 legs, one has 2 legs. The point is, each of these are different. That's why you learn to group and ungroup things. But in mathematics, instead of calling them groups and ungrouping, we call it expanding and factorizing. Instead of calling them animals, we call them terms. It's the same thing. So when you say, when do I ever use it? Well, you do use it logically. You just don't see the application to it. Yeah? But that's the reasoning. That's why we learn what's common, what's uncommon. All right? Now, if you didn't get that, it's okay. Today's lesson is just about you doing the mathematics, technique-wise. Yeah? Try this first example. Let's do the first rule. So we know distributive law now. Let's expand this bracket. So I've got something that's in common, 4, and I want to know the differences between this. I want to see how many groups I get, right? So let's see. Let's expand this. What would you do in the first step? Can I please have Ashwin? What do you do in the first step?
B plus B plus B.
Say it again.
B plus B plus B plus B.
Oh yeah, that's the long way. I want you to do short way now.
4 times B.
4 times B. Very good. So yes, you're right. It would have been 4 groups of B's and 4 groups of 3's, but I don't want you to do long way. I was showing it to you so you can see the logic. Once you know the logic, use the rule. So the rule is 4 groups of B is 4 times B. And what's 4 times B? Can I please have Tom? What's 4 times B written as?
4B.
4B. So it can be written as 4B, but that's what most students forget. They only do the first one. They have to also do the second term. So 4 groups of 3. I do want you to write down 4 times 3 is part of your notes so that you don't forget to do that. Separated by a plus sign because we're saying that's group 1, that's group 2. These two are different groups. I got 4 of those B's and I got 4 of those 3's. 4 times B we know is 4B plus 4 times 3. What is that, Wilbur? 12. Very good. Can I add these two terms together, Josh? Can I add them two together? So 4b plus 12, can I write 16b? No, you can't.
Hell no.
Why can't I? Why can't I, Tilly? Why can't I add 4b and 12 and write the answer 16b? Why can't I write this? Because this is wrong. Why can't I do... Shh, shh, shh. I'm asking Tilly. Tilly, why can't I do 4b plus 12? Yes, 12 is a constant term, but how do you know that's a constant term? It has no letters, but does this have a letter? Yeah, so they're different terms already. So this is like saying, if we're talking about fruits, that's like saying I've got 4 bananas. That's not a banana. You can't add them to say I've got 16 bananas. I only got 4 bananas. So that's why you can't group them together. They're different terms. Okay, they have to look exactly the same. So this one has letters, this one doesn't. So you can't add them together. That's wrong. The answer is 4b plus 12. Why does it get confusing? Because you've learnt timesing. If I gave you 4b times 12, yes, you can do this one. That's where the confusion is. So that one you can't add. This one you can times. Because again, 4b means 4 times b, and you're timesing by 12. You can times. You can switch the orders and do 4 times 12. That's okay. This one you can't. They're not the same. That's 4 groups of b, which is b plus b plus b plus b plus 12. They're so different. Okay? So if you actually expanded that one, this means b plus b plus b plus b. So you got 4 groups plus 12. How can you add them? Doesn't make sense. This one, you can. This one actually means 4 times 12 times b. And we know that 4 times 12 is? 48. Can you please copy this one down? Because I don't want to see this mistake on a test. When I do it on a test, it happens all the time. Addition versus multiplication. It's like the most infinite, most common problem you see at a year 8 level. Give it to any year 8 class. This is so common. The two differences between the two. They do the expansion, they get to the step, and then they do the next step, which is wrong. And it makes the whole answer wrong. Yeah, so you can't add that. That cannot be 16b. But this one can be 48b. Copy it down so you know the difference. One's addition, one's multiplication. Copy that down.
The right one is 4b.
Yeah, the right one's this one. That's why you can't add them. This is why you can't say it's 16b, because it doesn't make sense. You've got b plus b plus b plus b plus 12, and suddenly, somehow, you said 4 and 12 together gives you 16 b's. I did not have 16 b's, I only got 4 b's. See, 4 groups of b's is just 4 b's. How am I adding b's and 12s together? They're so different, right? Whereas this one is different. This one's one term. That's 4 times 12. That gives you 48. And I got 48 of those b's. That's what this means. Okay? This one is not saying I've got 16 b's. This one's just saying I've got 4 b's. I add a random 12. That's what this looks like. Okay? And that's why you can't group them. All right. Next example. Next example is just a negative problem that my year 9s tend to make a mistake. So if you lay it out correctly, you shouldn't make a mistake. So let's do it again. Outside number. What's the outside number? Can I please have Colleen? What's the outside number? -2. So when you multiply it, it's -2 times a. So write it down. -2 times a. That's the first one. Then you also have to multiply -2, 2. Now be careful, this one. It's -2 times -5, not just 5. Those who says 5, that's how you get it wrong. That number is a -5. Yeah, they come together. So the next line should be -2 times -5. If you don't put that negative, this answer is going to be wrong. Why is that? Because double negatives gives you positive. But if you don't put that negative, it becomes negative positive, which is a negative. So they're different. Yeah? So here we go. Let's work it out. -2 times a. What does that give me? Can I please have Oliver? -2 times a. -2a. So this now reduces to -2a. Next bit. What's -2 times -5? Let's go with Hauschwan. Say it again. Not -10. 10. Because double negatives make a positive. So it should be +10. Okay, so -2a plus 10. So be careful with the signs there. Okay, that's negative numbers from term 1. All right, so that's what I want to see. Just be careful with that negative. That's where students tend to make a mistake. Next one. And the last one. Last example for today is that, well, it doesn't always have to just be a number. The term at the front can be letters as well. So here we go. Let's focus on this one. Outside term is 3x. Distributive law says you've got to times them to every term inside the brackets. First one and second one. Here we go. First one should be 3x times 2x. Write that down. Plus 3x times 5y. Now, hopefully you've done some of your homework from exercise 5C and 5D. You would have practiced these types of skills. Let's go. Can I please have, who have I chosen? Leon. What's 3x times 2x?
6x squared.
Good. I thought you were going to be messing up with this. So 3 times 2 is 6. But remember, x times x is not 2x. The answer is x squared. So x times x is x squared. Okay, be careful with that one. Plus, let's do this one now. What's 3x times 5y? Let's go, Wendy.
15xy.
Beautiful. Okay, so again, they're all multiplying each other. The order doesn't matter. You can just do 3 times 5. It's 15. 15 times x? Well, I don't know what the answer is. And I don't know what times y is, so we just write it as 15xy. Can you add these two together? No, they're not like terms. One's an x squared, one's an xy group. They're not the same. So therefore you leave your answer here. Okay, yes, that's in powers, exactly. Yes. This is what you're practicing today. So those are the 3 different examples. One has negative, one's positive values, and the other one is with letters. Okay, this is your session to catch up. Remember your homework is 5G, 5H tomorrow as well. So you're going to keep up. Let's keep up. I'm going to stop the video.